students. On behalf of the teachers in Mathematics 8, I would like to welcome you all to school year 2020-2021. For weeks 1 and 2 of quarter 1, we shall be factoring completely different types of polynomials, specifically polynomials with common monomial factors, difference of two squares, sum and difference of two cubes, perfect square trinomials, general trinomials, and polynomials that could be factored by grouping. For this week's video, we shall be focusing on the first three objectives. I am Teacher Aiza, the one who will be with you in the first part of our lesson in factoring polynomials. Let's first consider the number 4. In what ways can we express this number? First, we can spell it out as the word four, F-O-U-R, or write it into its Roman numeral form, or its Hindu-Arabic form. It could also be the sum of 3 and 1, or the difference of 7 and 3, or the quotient of 16 and 4, and the product of 2 and 2. For weeks 1 and 2 of quarter 1, we shall be focusing on what 2 times 2 is. Writing 4 as 2 times 2 is the method called factoring. Factoring, therefore, is the process of writing an expression as the product of its factors. Let's start with the first type of factoring called the common monomial factoring. If we have the polynomial ax plus ay plus az, we can write that as the product of the factors a and the quantity x plus y plus z. A here is what we call the common monomial factor. How did we get it? If you notice these three terms here, a is common to them. Therefore, we have here our common monomial factor a. To get the other factor, x plus y plus z, all we need to do is divide ax, ay, and az by a. Here now is the pattern for common monomial factoring. Let's factor the polynomial 2x minus 10. Take a look at the term 2x and the term negative 10. What factor is common to both of them? It is 2. So, let's factor that out. Let's have the other factor by dividing both of these terms by the common monomial 2. 2x divided by 2 is x. Negative 10 divided by 2 is negative 5. 2 times the quantity x minus 5 is the factored form of the polynomial 2x minus 10. Let's check if our answer is correct. How do we do that? All we need to do is to simply multiply 2 times the quantity x minus 5 by making use of what we call the distributive property of multiplication over addition. Let's do it. 2 times x is equal to 2x. 2 times negative 5 is equal to negative 10. The product we obtained in the checking is the same with the original given expression. Therefore, we have obtained the correct factored form of 2x minus 10, which is 2 times the quantity x minus 5. Let's proceed with our second example. We are now to factor out the polynomial 3x cubed minus 12x squared plus 9x. Let us first focus ourselves on the numerical coefficients 3, negative 12, and 9. What factor is common to these three? It is 3. Now, let's move on to the factor common to the literal coefficients x cubed, x squared, and x. It is x. The product of 3 and x, which is 3x, is the common monomial factor to the given polynomial 3x cubed minus 12x squared plus 9x. Let us now divide all of these terms by the common monomial 3x to obtain our second factor. 3x cubed divided by 3x is x squared. Negative 12x squared divided by 3x is negative 4x. 9x divided by 3x is 3. The other factor is the quantity x squared minus 4x plus 3. Let us now check if the factors we obtained are correct by applying DPMA. So, we again multiply the factors we obtained. 3x times the quantity x squared minus 4x plus 3. 3x times x squared equals 3x cubed. 3x times negative 4x is negative 12x squared. And lastly, 3x times 3 is equal to 9x. Notice that the product we obtained in the checking is the same with the original expression. Therefore, we have arrived at the correct factored form of 3x cubed minus 12x squared plus 9x, which is 3x times the quantity x squared minus 4x plus 3. It's your turn now, math student. Don't forget to check your answer. Your timer starts now. The correct factored form of 8m cubed n raised to 4 plus 4m squared n raised to 4 is 4m squared m raised to 4 times the quantity 2m plus 1. A perfect square is a number that can be expressed as the product of two equal numbers. Examples: 49 is a perfect square since it can be expressed as the product of 7 and 7. X squared is a perfect square since it can be expressed as the product of x and x. You need to study this list for the next type of factoring. For the second type of factoring, difference of two squares, we shall first meet three conditions. First, difference. The terms must be separated by the minus sign. Second, 2. The polynomial must be composed of two terms. Therefore, it must be a binomial. And lastly, squares. The two terms of the binomial must be both perfect squares. So let's have the polynomial x squared minus y squared. Is this a difference of two squares? First, are the terms separated by the minus sign? Yes. Do we have a binomial? Yes. And are the two terms x squared and y squared perfect squares? Yes. So, how do we factor out a polynomial that is a difference of two squares? We need to extract the square root of the first term x squared. Its square root is x. And we need to extract the square root of y squared. Its square root is y. Let us now write the factored form of x squared minus y squared. We have here the product of the sum and the difference of the square root of x squared and the square root of y squared. We could also rewrite this as the quantity x minus y times the quantity x plus y, since multiplication is commutative. Here now is our pattern for the difference of two squares. Let's find out if the polynomial x squared minus 9 is a difference of two squares, and then factor it out. First condition, Are the terms separated by the minus sign? Yes. Do we have a binomial? Yes. And are the two terms perfect squares? Yes. Therefore, we can factor this out using the pattern that we have had a while back. How do we do that again? Extract the square root of x squared. That would be x. Next, extract the square root of 9. It is 3. Now, it's time for us to write that in factored form. We have again the product of the sum and the difference of the square root of x squared, which is x, and the square root of 9, which is 3. Again, we can rewrite that as the quantity x minus 3 times the quantity x plus 3. Let's find out if the factors we have obtained are correct. Let's do the checking. Again, all we need to do here is to apply DPMA. But since we have two binomials that are being multiplied to each other, we can actually make use of the FOIL method. Let's do that. First terms first. X times x equals x squared. Let's multiply the outer terms. X times 3 is 3x. This time, the inner terms. Negative 3 times x is negative 3x. And finally, the last terms. Negative 3 times 3 is negative 9. Let us combine similar terms. The two terms here, 3x and negative 3x, would give us a 0. Therefore, we are left with x squared minus 9. Notice that the product we obtained in the checking is the original expression x squared minus 9. Therefore, we have arrived at the correct factored form of x squared minus 9, which is the quantity x plus 3 times the quantity x minus 3. Let's work on 4b raised to 4 minus 25c squared for our second example. This is a difference of two squares since the terms are separated by the minus sign. The polynomial has two terms, meaning to say it is a binomial. These terms, 4b raised to 4 and 25c squared, are perfect squares. Let's factor that out. Extract the square root of 4b raised to 4. It is 2b squared. Extract the square root of 25c squared. It is 5c. Now, let's write that in its factored form. We have the product of the sum and the difference of the square root of 4b raised to 4, which is 2b squared, and the square root of 25c squared, which is 5c. We can rewrite that as the quantity 2b squared minus 5c times the quantity 2b squared plus 5c. There is a need for us to check if our answer is correct. We make use of the FOIL method. The quantity 2b squared plus 5c times the quantity 2b squared minus 5c is equal to first term times first term equals 4b raised to 4. Outer term times outer term equals negative 10b squared c. Inner term times inner term equals 10b squared c. And last term times last term equals negative 25c squared. Let us combine similar terms. These two terms here are similar, but when simplified will give us a 0. Therefore, we are left with 4b raised to 4 minus 25c squared. Again, the product we obtained in our checking is the same with the given expression. Therefore, we have obtained the correct factored form of 4b raised to 4 minus 25c squared, which is the quantity 2b squared plus 5c times the quantity 2b squared minus 5c. It's your turn now, math student. Don't forget to check your answer. Your timer starts now. The correct factored form of 16y squared minus 100 is the quantity 4y plus 10 times the quantity 4y minus 10. A perfect cube is a number that can be expressed as the product of three equal numbers. Examples: 64 is a perfect cube since 64 can be expressed as the product of 4, 4, and 4. X cubed is a perfect cube since it can be expressed as the product of x, x, and x. You need to study this list for the next type of factoring. The last objective for today is for us to factor polynomials that are sum or difference of two cubes. For this particular type, we again need to pass through three conditions. First, cubes. We must have perfect cubes. Next, 2. The polynomial must be composed of two terms. Therefore, we must have a binomial. And lastly, the two terms in our binomial must be separated by either the plus sign or the minus sign. X cubed plus y cubed is a sum of two cubes, while x cubed minus y cubed is a difference of two cubes. How do we factor polynomials of this kind? Here's how we are going to do it. Extract the cube root of the first term. The cube root of x cubed is x. Extract the cube root of the last term. The cube root of y cubed is y. Then follow the operation of the original binomial. The operation here is addition, therefore x and y must be separated by the plus sign. This is our binomial factor. We have a second factor, and it is a trinomial. Let us now have our second factor. First, get the square of the first term of the binomial factor. The square of x is x squared. Next, get the square of the second term of the binomial factor. The square of y is y squared. To obtain the middle term of our trinomial factor, what we need to do is to multiply the first term by the second term of our binomial factor. X times y is xy. And we need to follow the pattern of the signs. If this is plus, the one here should be minus, and the one here is plus. So the pattern of the signs for a sum of two cubes is plus, minus, plus. For a difference of two cubes, we follow the same steps. Extract the cube root of the first term. That would be x. Then extract the cube root of the second term. In this particular case, that would be y. And then we follow the operation of the given binomial. So minus sign separates the cube roots of x cubed and y cubed. For our trinomial factor, we shall be having the square of the first term, x squared, followed by the square of the last term, that is y squared. For the middle term of our trinomial factor, we multiply the first term of the binomial factor and the last term of that same factor. So we have x times y is xy. For the pattern of the signs, we shall be following minus, plus, and plus. Let me repeat that. For a difference of two cubes, the pattern of the signs is minus, plus, and plus. These are now the patterns we are going to follow when we are factoring sum or difference of two cubes. Let's find out if the polynomial a cubed plus 27 is a sum of two cubes, and then factor it out if it is. First, do we have perfect cubes? Yes, a cubed and 27 are perfect cubes. Is the polynomial composed of two terms? Yes, the polynomial is composed of the terms a cubed and 27. And lastly, are the terms separated by the plus sign? Yes. Therefore, we can apply the pattern in factoring sum of two cubes. How do we do that again? We extract the cube root of a cubed. It is a. Then extract the cube root of 27. It is 3. After which, we follow the sign of the original binomial. So we have here plus. Let us now write our second factor. Again, it is a trinomial. First, square the first term of the binomial factor. The square of a is a squared. Then, square the last term. The square of 3 is 9. For our middle term of the trinomial factor, we multiply a and 3. A times 3 is 3a. And again, follow the pattern of the signs. Plus, minus, plus. Let's see if the factors we obtained here are correct by, again, applying the distributive property of multiplication over addition, or what we call DPMA. Let's multiply the quantity a plus 3 and the quantity a squared minus 3a plus 9. A times a squared is a cubed. A times negative 3a is negative 3a squared. A times 9 is 9a. Next, 3 times a squared is 3a squared. 3 times negative 3 is negative 9a. And lastly, 3 times 9 is 27. Let us now simplify our answer by combining similar terms. Negative 3a squared and positive 3a squared when combined will give us a 0. And 9a and negative 9a when simplified will again give us a 0. Therefore, we are left with a cubed plus 27. The product we obtained and the original expression are the same. Therefore, we have arrived at the correct factored form of a cubed plus 27, which is the quantity a plus 3 times the quantity a squared minus 3a plus 9. For our final example for today's session, we have the polynomial 8m cubed minus 1. Is this a difference of two cubes? Yes, it is. Why? Because we have a polynomial that is composed of two terms. Both terms are perfect cubes, and these terms are separated by the minus sign. Therefore, we can follow the pattern in factoring difference of two cubes. Let's have the cube root of 8m cubed, which is 2m. The cube root of 1, which is 1. We follow the sign in the original binomial. So we have here the minus sign. For the second factor, which is a trinomial, we square 2m. The square of 2m is 4m squared. Then we square 1. Its square is 1. And for the middle term of our trinomial factor, we multiply 2m and 1. The product is 2m. Remember the pattern of the signs? Minus, plus, and plus. Let's find out if the factors that we have obtained are correct by doing the DPMA. We multiply the quantity 2m minus 1 by the quantity 4m squared plus 2m plus 1. 2m times 4m squared is 8m cubed. 2m times 2m is 4m squared. 2m times 1 is 2m. Negative 1 times 4m squared is negative 4m squared. Negative 1 times 2m is negative 2m. And finally, negative 1 times 1 is negative 1. Let's simplify this answer by combining similar terms. 4m squared minus 4m squared is 0. 2m minus 2m is 0. Therefore, we are left with 8m cubed minus 1. Notice that the product we obtained in our checking is the same with the given expression. Therefore, we have arrived at the correct factored form of 8m cubed minus 1, which is the quantity 2m minus 1 times the quantity 4m squared plus 2m plus 1. It's your turn now, math student. Don't forget to check your answer. Your timer starts now. The correct factored form of x cubed plus 125 is the quantity x plus 5 times the quantity x squared minus 5x plus 25. It's your turn now, math student. Don't forget to check your answer. Your timer starts now. The correct factored form of y cubed minus 1 over 8 is the quantity y minus 1/2 times the quantity y squared plus 1/2 y plus 1/4. Let's recall the three types of factoring that we have learned this week. First, common monomial factoring. All the terms in the given expression must have a common factor. Second, difference of two squares. We must have a binomial separated by the minus sign, and the two terms in the given binomial must be perfect squares. And lastly, the sum and difference of two cubes. Again, we have a binomial. The terms of the binomial are perfect cubes, and these terms must be separated by either the minus or the plus sign. Always remember, when we factor these types of polynomials, we follow these rules. Congratulations, learners! Another set of treasures has been added to your learning box. See you again next week for the second part of our lesson on factoring polynomials. Let's start with the first type product we obtained in the checking is the same with the given. The product we obtained The product we obtained.
Congratulations, students! Another set of treasures has been Congratulations, students! Another set of treasures has been Another set of treasures has been added. Congratulations, students! Congratulations, students! Another set of treasures has been added to your learning box. Another set of treasures has been added to your Another set of treasures has been added to your learning box. See you again next week for the second part of our lesson on factoring.